The universe is an endless ocean of darkness, dotted with islands of light, yet most of it remains hidden from us, whispering secrets we've only begun to unravel. Picture this: out there in the silent depths of space, entire galaxies are being pulled toward an invisible force we can't explain. Strange signals flicker across the cosmos, vanishing before we can decode them. And some corners of the void are so empty, they defy everything we know about how the universe should work. These aren't just gaps in our knowledge, they're screaming mysteries waiting to be solved. Today, we're diving into 25 of the most baffling enigmas lurking in the cosmic shadows. From the eerie Great Attractor dragging galaxies off course to the bizarre, wow signal that still haunts astronomers decades later, each one challenges what we think we understand about reality. So buckle up, we're about to journey into the unknown, where the rules of physics twist and the answers might just rewrite existence itself. And trust me, by the end, you'll never look at the night sky the same way again. Now, let's turn our attention to the first mystery on our list, the Great Attractor. Imagine a force so powerful it's dragging entire galaxies, including our own Milky Way, toward it at breakneck speeds. Yet, despite its immense influence, we can't even see it. This invisible behemoth lies hidden behind the dense stars and dust of our galaxy's plane, making it one of the most frustrating puzzles in modern astronomy. Scientists estimate the Great Attractor sits roughly 250 million light-years away in the direction of the constellations Centaurus and Norma. But peering through the Milky Way's crowded core is like trying to spot a distant lighthouse through a thick fog. Even our most advanced telescopes struggle to pierce through the cosmic clutter. So what could this mysterious force be? One leading theory suggests it's a colossal cluster of dark matter, an unseen gravitational anchor pulling galaxies into its grasp. Others speculate it might be something even stranger, a flaw in the fabric of space-time itself, a cosmic wrinkle left over from the universe's earliest moments. But here's the twist: recent observations hint that the Great Attractor might just be part of an even larger structure, a supercluster of galaxies with unimaginable mass. This raises even more questions. Does the pull we feel come from one dense knot of matter, or is it the combined tug of countless galaxies moving together? Whatever the answer, the Great Attractor reminds us that even in an age of cutting-edge astronomy, the universe still holds secrets just out of reach. And as we inch closer to unraveling this enigma, we might just uncover truths that reshape our understanding of gravity, dark matter, and the very structure of the cosmos. Next up, we'll explore another eerie phenomenon: galaxies moving in unison towards something beyond the edge of our observable universe. The mystery of dark flow awaits. Now, shifting our gaze to an even stranger cosmic puzzle, we encounter the baffling phenomenon known as dark flow. Picture this: galaxy clusters scattered across the universe, all drifting in the same direction like leaves caught in a hidden current. But here's what makes it truly unsettling: this motion can't be explained by anything within our observable universe. It's as if some unseen force, far beyond the edges of what we can see, is tugging them along. Scientists first noticed this eerie movement while studying the cosmic microwave background, the faint afterglow of the Big Bang. They expected galaxies to move randomly, influenced by nearby gravitational pulls. Instead, they found hundreds of clusters streaming toward a single point in space, as if drawn by something colossal lurking in the void. So what could be causing this? One daring theory suggests the pull might come from another universe entirely, a parallel cosmos exerting gravitational influence on ours. Imagine the fabric of reality as a sheet of paper with multiple sheets stacked together. If another universe brushed against ours, it could create ripples strong enough to nudge galaxies in ways we can't yet fully explain. Another possibility points to the aftermath of the Big Bang itself. Cosmic inflation, the rapid expansion of the early universe, might have left behind gravitational waves or uneven densities that still tug at matter today. Think of it like wrinkles in a bed sheet. Some regions could have more pull than others, steering galaxies in a shared direction, yet dark flow remains hotly debated. Some argue it's a statistical fluke, while others see it as a clue to something far grander, perhaps evidence that our universe is just one piece of a much larger, stranger puzzle. Whatever the truth, this phenomenon challenges our understanding of gravity, the limits of the cosmos, and what might lie beyond the horizon of our observations. Up next, we'll confront one of the most famous paradoxes in space science: why, in a universe teeming with potential for life, we seem utterly alone. The Fermi Paradox awaits. Now, let's tackle one of the most perplexing questions in all of science, the Fermi Paradox. If the universe is so vast with billions of stars and planets, why haven't we found any signs of intelligent life? It's a contradiction that's haunted astronomers for decades. The numbers alone suggest we shouldn't be alone. Our galaxy, the Milky Way, holds hundreds of billions of stars, many with planets in the so-called Goldilocks zone, where conditions are just right for life. With so many potential homes for civilizations, why does the cosmos seem silent? One chilling explanation is the Great Filter. This theory suggests there's some catastrophic barrier that prevents life from advancing beyond a certain point. Maybe it's the rarity of life itself, or perhaps civilizations tend to self-destruct before they can colonize the stars. If that's true, the question becomes, have we already passed the filter, or is it still ahead of us waiting to wipe us out? Then there's the zoo hypothesis. Imagine advanced civilizations know we're here but choose not to interfere, treating Earth like a protected wildlife reserve. They might be observing us from afar, waiting for humanity to reach a certain level of maturity before making contact. It's a comforting thought, but it raises another question. Why would every single alien society agree to stay silent? Another angle is the sheer difficulty of interstellar communication. The distances between stars are so vast that even light takes years to cross them. By the time a signal reaches another civilization, that society might have already collapsed or evolved beyond recognition. Or perhaps they're using technologies we can't even detect, leaving us oblivious to their presence. Some argue we're simply not looking hard enough. The universe is enormous, and our search for extraterrestrial intelligence is still in its infancy. Others believe we're alone, that Earth is a 1 in a trillion fluke. Whatever the answer, the Fermi Paradox forces us to confront our place in the cosmos. Are we special or just early? Next up, we'll dive into a mysterious signal from space that sparked decades of speculation, the WOW signal. Was it a cosmic coincidence or something far more intriguing? Now, let's turn our attention to one of the most tantalizing mysteries in the search for extraterrestrial intelligence, the WOW signal. Back in 1977, a radio telescope in Ohio picked up something extraordinary. For 72 seconds, a powerful, narrowband signal blared from deep space, so unusual that the astronomer who discovered it circled the data and wrote, "Wow," in the margin, giving the signal its iconic name. What made this signal so special? It matched the exact frequency scientists predicted an alien transmission might use, the hydrogen line, around 1420 MHz. Natural cosmic noise usually spreads across many frequencies, but this was a clean, focused burst, the kind you'd expect from an intentional broadcast. Even stranger, it came from the direction of the constellation Sagittarius, a region packed with stars but no obvious cosmic events that could explain it. Decades later, the WOW signal remains unexplained. Some argue it could have been a comet's hydrogen cloud reflecting sunlight, but the timing and location don't quite add up. Others suggest it might have been a passing satellite or military transmission, yet no records match the signal's unique profile, the most intriguing possibility. A fleeting message from an advanced civilization, one that hasn't repeated, at least not in a way we've detected. Despite countless searches, the signal never reappeared. Was it a cosmic coincidence, a glitch, or something far more deliberate? The mystery endures, a reminder of how much we still don't understand about the universe's whispers. Next, we'll explore another enigma: fast radio bursts, those fleeting but powerful blasts of energy from the depths of space. What could be sending them, and why do they vanish as quickly as they appear? Now, shifting our gaze to another cosmic puzzle, let's dive into the baffling world of fast radio bursts. These are fleeting, ultra-powerful blasts of radio waves that streak across the universe in just milliseconds, packing more energy than the sun emits in days. First detected in 2007, these bursts arrive without warning, vanishing almost as quickly as they appear, leaving astronomers scrambling for answers. What makes them so mysterious? For one, their origins are scattered across the cosmos, some billions of light years away. Unlike the steady pulses of pulsars or the predictable glow of quasars, fast radio bursts are erratic. Some repeat randomly, while others fire once and never return. This unpredictability makes them incredibly hard to study. So what could be causing them? One leading theory points to magnetars, highly magnetic neutron stars that occasionally unleash violent flares. In 2020, astronomers even caught a magnetar in our own galaxy emitting a fast radio burst-like signal, adding weight to the idea. But not all bursts fit this explanation. Some repeat in patterns too orderly for stellar tantrums, sparking wilder speculation. Could they be signatures of advanced alien technology, like interstellar beacons or even spacecraft propulsion? Then there's the sheer power behind these bursts. To travel such vast distances and still reach us with detectable strength, whatever produces them must be unimaginably energetic. Yet, despite their intensity, no visible light or other radiation accompanies them, deepening the enigma. With every new detection, fast radio bursts challenge our understanding of the universe's most extreme phenomena. Are they cosmic accidents, natural but unknown processes, or something even more extraordinary? As telescopes grow more sensitive, we may finally crack their code or uncover even deeper mysteries. Up next, we'll venture into one of space's emptiest realms, the Boötes Void, a staggering cosmic desert where galaxies are almost nowhere to be found. What carved out this vast nothingness, and what does it reveal about the universe's structure? Now, let's journey into one of the universe's most hauntingly empty places, the Boötes Void. Picture a region of space so vast it could fit thousands of Milky Way galaxies side by side, yet it's almost completely devoid of them. Stretching an astonishing 330 million light-years across, this cosmic desert is one of the largest known voids in existence, earning it the nickname the Great Nothing. How does something like this even form? Normally, galaxies cluster together like cities in a vast cosmic web, connected by filaments of gas and dark matter. But the Boötes Void defies that pattern. Instead of bustling galactic metropolises, it's a sprawling wasteland with only a handful of galaxies scattered like lone outposts. One leading theory suggests it might be the result of smaller voids merging over billions of years, like bubbles combining to create a colossal empty pocket. Another idea points to an early universe anomaly, a region where matter was unusually sparse from the beginning, leaving it barren as the cosmos expanded. What makes this void so puzzling isn't just its size, but what it tells us about the universe's structure. According to the cosmological principle, matter should be evenly distributed on the largest scales. But the Boötes Void challenges that assumption, hinting that the universe might be more uneven or more mysterious than we thought. Could there be forces or phenomena we haven't yet discovered that carve out such emptiness? Even more intriguing is what the void means for cosmic inflation, the rapid expansion of the early universe. If voids like this are more common than expected, it might mean inflation wasn't as smooth as our models suggest. Or perhaps these voids are the aftermath of cosmic collisions with other universes in the multiverse. A wild idea, but one that scientists can't entirely rule out. For now, the Boötes Void remains a silent enigma, a reminder that the universe still holds vast, unexplored frontiers. Up next, we'll turn our attention to a star whose strange flickers have sparked debates about alien megastructures, Tabby's star. Could its bizarre behavior be the key to unlocking another cosmic mystery? Now, shifting our gaze from the eerie emptiness of the Boötes Void, we arrive at a star that's anything but ordinary, Tabby's star, also known as KSE 8462852. This distant sun, located roughly 1,400 light-years away in the constellation Cygnus, has baffled astronomers with its unpredictable and dramatic dimming. Unlike most stars which dim in regular, predictable patterns due to orbiting planets, Tabby's star flickers erratically, sometimes dropping in brightness by as much as 22%. That's like someone turning a porch light nearly off and back on again at random intervals. When this behavior was first spotted by NASA's Kepler Space Telescope in 2015, it sparked a firestorm of speculation. The most tantalizing early theory, alien megastructures. Some scientists wondered if an advanced civilization had built a Dyson swarm, a vast array of energy-collecting satellites encircling the star. It was a thrilling idea, but as always, science demanded more evidence. Since then, researchers have proposed less exotic but equally fascinating explanations. One leading theory points to massive clouds of dust orbiting the star, possibly from shattered comets or colliding planets. These clouds could block starlight unevenly, creating the strange dimming patterns. Another idea suggests a family of giant, fragmented planets with trailing debris fields, casting irregular shadows as they pass in front of the star. What makes Tabby's star so compelling is that none of these explanations fully account for all its quirks. The dust theory, for example, doesn't perfectly match the star's long-term fading trends. And while alien megastructures remain a remote possibility, the lack of telltale infrared heat signatures makes it unlikely. This star refuses to fit neatly into any box, keeping astronomers on their toes. Ongoing studies, including observations from ground-based telescopes and future missions like the James Webb Space Telescope, aim to crack this cosmic puzzle. Whether the answer lies in cosmic dust, planetary wreckage, or something even stranger, Tabby's star reminds us that the universe is full of surprises. Next up, we'll confront a mystery that challenges the very foundations of cosmology, the unsettling alignment known as the axis of evil. Now, let's turn our attention to something that sounds like it's straight out of a cosmic thriller, the axis of evil. This isn't some villainous plot, but a spine-chilling alignment in the very fabric of the universe that has left scientists scratching their heads. The story begins with the cosmic microwave background, or CMB, the afterglow of the Big Bang. This faint radiation fills the entire universe, and its tiny temperature fluctuations are like fingerprints from the birth of everything we know. But here's the twist: when scientists mapped these fluctuations, they noticed something bizarre. The patterns weren't random. Instead, they seemed to align eerily with the plane of our solar system. It's as if the universe itself is pointing a finger at us, and that's downright unsettling. This alignment, dubbed the axis of evil, challenges one of cosmology's most sacred principles, the cosmological principle, which states that the universe should look roughly the same in all directions. If the CMB's fluctuations aren't random, it could mean our place in the cosmos isn't as ordinary as we thought. Some researchers argue it's just a statistical fluke, a cosmic coincidence. But others wonder if it hints at something deeper, a fundamental bias in the structure of the universe, or even evidence of a pre-Big Bang influence. The implications are staggering. If the axis of evil isn't a fluke, it could mean our understanding of the universe's origins is incomplete. Maybe the Big Bang wasn't the true beginning, or perhaps some unseen force shaped the early cosmos in ways we can't yet explain. Skeptics, of course, point out that human perception loves finding patterns, even where none exist. But with multiple studies confirming the anomaly, it's hard to dismiss entirely. For now, the axis of evil remains one of cosmology's most perplexing puzzles. Future missions, like more precise CMB mapping, could shed light on whether this alignment is real or just a trick of the data. Either way, it's a humbling reminder that the universe still holds mysteries capable of shaking the foundations of science. Next, we'll dive into the invisible forces that dominate the cosmos, dark matter and dark energy, and why they're even more mysterious than they sound. Now, let's peel back the curtain on the universe's greatest enigmas, dark matter and dark energy. These invisible forces don't just lurk in the shadows, they dominate the cosmos, shaping everything from the tiniest galaxies to the vast expanse of space itself. Yet, despite their overwhelming influence, we still don't fully understand what they are. First, consider dark matter. It's the cosmic glue holding galaxies together. Without it, stars would fly apart like marbles spilled across a floor. We can't see it, touch it, or detect it directly, but its gravitational pull is unmistakable. Galaxies rotate faster than they should, and clusters bend light in ways that defy the laws of visible matter alone. Scientists have proposed particles like WIMP, weakly interacting massive particles, as potential candidates, but after decades of searching, dark matter remains elusive. Then there's dark energy, the mysterious force accelerating the universe's expansion. Imagine blowing up a balloon that inflates faster and faster without any extra air. That's what dark energy is doing to space itself. Discovered in the late 1990s through observations of distant supernova, this phenomenon upended our understanding of cosmic fate. Instead of slowing down, the universe is speeding apart, and dark energy is the unseen driver. Some theories point to vacuum energy or a new fundamental field, but the truth is still out there. What makes these forces so baffling is how they oppose each other. Dark matter pulls, binding the cosmos together, while dark energy pushes, tearing it apart. Together, they make up roughly 95% of the universe's total content, leaving the ordinary matter we know, stars, planets, us, as a mere afterthought. The hunt for answers continues. Underground labs search for dark matter particles, while telescopes map dark energy's effects across billions of light years. Each discovery brings new questions, reminding us that the universe is far stranger than we ever imagined. Next, we'll unravel the myth of the Black Knight satellite, a tale of conspiracy, space debris, and the enduring allure of cosmic mysteries. Now, let's shift our gaze from the invisible forces shaping the cosmos to a mystery much closer to home: the legend of the Black Knight satellite. This enigmatic object, said to be an ancient alien craft silently orbiting Earth, has fueled decades of speculation, conspiracy theories, and wild imaginations. But what's the real story behind this so-called extraterrestrial sentinel? The myth began in the 1950s when reports surfaced of an unidentified object circling our planet. Some claimed it was a relic from an advanced alien civilization, perhaps monitoring humanity for thousands of years. The stories grew wilder. Some said it transmitted strange radio signals, while others insisted it was proof of secret space programs. But let's separate fact from fiction. Most of the Black Knight's lore stems from misinterpretations. For instance, in 1960, the United States discovered an unexpected object in orbit, only to realize it was the remains of a Discoverer satellite, part of a Cold War-era reconnaissance program. Then there's the famous Black Knight photograph from 1998, often cited as evidence. In reality, it showed a thermal blanket lost during a spacewalk, tumbling harmlessly in orbit. Even the idea of an ancient satellite defies physics. Without maintenance, any man-made object would decay and re-enter Earth's atmosphere within centuries, let alone millennia. And while space is littered with debris, old rocket parts, defunct satellites, and other fragments, none of it points to alien origins. So why does the myth persist? Part of it is our fascination with the unknown. The black night taps into a deep-seated curiosity about whether we're being watched or if something out there knows more than we do. It's a reminder of how easily the line between mystery and misunderstanding can blur. As we continue our journey through the cosmic void, next up is another puzzle closer to home. The Pioneer anomaly, where two spacecraft defied expectations in ways that still leave scientists scratching their heads. Now, let's turn our attention to another cosmic head-scratcher, the Pioneer anomaly. Back in the 1980s, scientists noticed something odd about the Pioneer 10 and 11 spacecraft. These probes, launched in the early 1970s to explore the outer solar system, were slowing down just a tiny bit more than expected. At first glance, the difference seemed minuscule, less than a billionth of the acceleration we feel from Earth's gravity. But in the precise world of space physics, even the smallest discrepancy can hint at something big. For years, this anomaly puzzled researchers. Some wondered if it was a sign of new physics, maybe an unseen force or a flaw in our understanding of gravity. Others speculated about dark matter's influence or even tiny errors in tracking the probes. But the most likely explanation turned out to be far simpler: heat. The Pioneer's radioactive power sources emitted warmth, and as that thermal radiation bounced off the spacecraft's uneven surfaces, it created a slight push enough to account for the extra slowdown. Yet, even with this explanation, questions linger. While thermal radiation covers most of the anomaly, some measurements still don't quite add up. Could there be another factor at play? Or is it just a matter of refining our models? The Pioneer anomaly reminds us that space is full of subtle surprises, and sometimes the answers we find lead to new questions. As we venture deeper into the cosmic unknown, our next stop takes us to an interstellar visitor that defied expectations: the mysterious object known as Oumuamua. Now, let's shift our gaze to one of the most baffling visitors from beyond our solar system, Oumuamua. This strange, cigar-shaped object zipped through our cosmic neighborhood in 2017, and it left scientists scratching their heads from the moment it was spotted. Unlike any asteroid or comet we've seen before, Oumuamua didn't just coast passively through space. It accelerated slightly as it moved away from the Sun, defying the usual rules of gravity. At first, astronomers assumed it was a simple interstellar rock, but its behavior told a different story. Most comets speed up due to outgassing when sunlight vaporizes their icy surfaces, creating a kind of natural jet engine. But Oumuamua showed no visible tail or coma, the fuzzy halo typical of outgassing comets. So what was pushing it? One theory suggests it might have been a hydrogen iceberg, a chunk of solid hydrogen that evaporates invisibly in sunlight, providing just enough thrust to explain the acceleration. Another idea points to cosmic radiation pressure, though the numbers don't quite match up. Then, of course, there's the more speculative angle. Could Oumuamua have been artificial? Its unusual shape and motion sparked wild theories, including the possibility of an alien light sail, a technology designed to harness sunlight for propulsion. While most scientists lean toward natural explanations, the lack of a definitive answer keeps the debate alive. What makes Oumuamua truly remarkable isn't just its mystery. It's the fact that it's our first confirmed interstellar visitor, a glimpse into the building blocks of other star systems. Whether it was a weirdly shaped space rock or something even more extraordinary, its brief appearance challenged our assumptions and reminded us that the universe still has plenty of surprises up its sleeve. And speaking of cosmic surprises, our next mystery takes us to a problem closer to home, or rather, closer to the fabric of the universe itself. The missing baryon problem asks why half the normal matter in the cosmos seems to have vanished without a trace. Now, let's unravel a cosmic detective story that's been puzzling scientists for decades: the case of the missing baryons. You might think we've got a pretty good handle on what the universe is made of, but here's the twist: about half the normal matter, the stuff that makes up stars, planets, and even us, has seemingly vanished without a trace. Here's the mystery in a nutshell. Based on observations of the early universe, like the cosmic microwave background, we can calculate how much ordinary matter, or baryons, should exist today. But when astronomers tally up all the visible galaxies, stars, and gas clouds, they come up shockingly short. Where did the rest go? The leading theory points to an invisible web of super-hot gas filaments stretching between galaxies, known as the cosmic web. These threads are so diffuse and scorching millions of degrees hot that they don't emit much light, making them nearly impossible to spot with traditional telescopes. Think of it like trying to see steam rising from a boiling pot in a pitch-black room. Recent breakthroughs, though, are starting to shed light on this hidden realm. By using X-ray telescopes and studying how light from distant quasars gets absorbed as it passes through space, scientists have detected whispers of these elusive baryons. Some even lurk in vast, low-density regions called WIM, the warm, hot intergalactic medium where matter is so spread out, it's like finding a single grain of sand in an Olympic-sized swimming pool. So why does this matter? Because baryons are the building blocks of everything we see. If we can't account for half of them, it means our cosmic inventory is incomplete, leaving gaps in our understanding of how the universe evolved. It's a humbling reminder that even the familiar stuff, the atoms in our bodies, can hide in plain sight when the universe decides to play hide and seek. And just when you think space can't get any stranger, our next mystery takes us to a structure so colossal, it defies the very laws of cosmology: the Hercules Corona Borealis Great Wall. Now, let's turn our gaze to something so vast it bends the rules of the cosmos itself: the Hercules Corona Borealis Great Wall. Picture this: a sprawling tapestry of galaxies stretching over 10 billion light-years, making it one of the largest known structures in the universe. To put that into perspective, if our Milky Way were a single grain of sand, this wall would be the size of an entire beach. What makes this colossal structure so baffling? It defies a fundamental idea in cosmology called the cosmological principle, which states that on a large enough scale, the universe should look roughly the same no matter where you are. But the Hercules Corona Borealis Great Wall throws a wrench into that assumption. Its sheer size and density of galaxies challenge the notion of cosmic uniformity, as if the universe decided to build a skyscraper in a neighborhood where everything else is supposed to be flat. Scientists first spotted this behemoth by mapping gamma-ray bursts, the brightest explosions in the universe, which act like cosmic breadcrumbs tracing the distribution of matter. The bursts revealed an unexpected concentration of galaxies, clumped together in a way that shouldn't be possible under standard models of the universe's evolution. Some theories suggest it could be a remnant of ancient gravitational waves, or a rare fluctuation in the early universe's density. Others wonder if we're seeing the shadow of something even more mysterious lurking beyond our current understanding. The existence of this great wall forces us to rethink how structures form in the cosmos. Is it a statistical fluke, or is there a deeper, unseen force at work? Either way, it's a humbling reminder that the universe still holds surprises on scales we're only beginning to comprehend. And just when you think the cosmos can't get any more enigmatic, our next mystery takes us to a chilling, cold spot in the fabric of space-time: the Eridanus supervoid. Now, let's step into the eerie quiet of the Eridanus supervoid, a cosmic cold spot that feels like a ghostly fingerprint on the universe. Imagine staring at a thermal map of the night sky, where everything glows with the faint warmth of the cosmic microwave background, the afterglow of the Big Bang, and then suddenly, there it is, a patch so cold it sends shivers down the spine of astrophysics. This isn't just a minor dip in temperature. The Eridanus supervoid spans an astonishing 1 billion light-years, a staggering emptiness where galaxies are strangely scarce. It's as if someone carved out a chunk of the universe and left behind a cosmic vacuum. But here's the twist: this void might not be empty at all. Some scientists believe it could be a supervoid, a region where matter is so thinly spread that light passing through loses energy, creating that chilling cold spot in the cosmic microwave background. Yet not everyone's convinced. The size and depth of this cold spot defy easy explanation. Could it be a rare statistical fluke, a cosmic coincidence in the vast tapestry of the universe? Or is it something far stranger, like the shadow of a collision with another universe? That's right. Some theories suggest this void might be a bruise left by a parallel universe bumping into ours, a crack in the fabric of reality itself. Of course, not all researchers are ready to jump to multiverse conclusions. Alternative explanations point to quirks in the early universe's density or even gaps in our own observations. But whether it's a cosmic oversight or evidence of something beyond our dimension, the Eridanus supervoid forces us to confront a humbling truth. The universe still holds pockets of mystery that refuse to fit neatly into our models. And as we peel back the layers of this cosmic enigma, our next stop takes us to the edge of our solar system, where the Kuiper Cliff waits like a silent boundary no one saw coming. Now let's journey to the outer edges of our solar system, where the Kuiper belt holds a mystery as abrupt as it is baffling. Picture this vast ring of icy debris, home to Pluto and countless other frozen objects stretching billions of miles beyond Neptune. But just when you'd expect it to fade gradually into the darkness of space, something strange happens. The Kuiper Cliff, this isn't a gentle tapering off. It's a sudden, dramatic drop in the number of objects, as if someone drew a line in the cosmic sand. One moment, the Kuiper belt is bustling with icy rocks and dwarf planets, and the next, it's eerily sparse. Scientists call this sharp boundary the Kuiper Cliff, and its existence challenges everything we thought we knew about the solar system's formation. So, what could explain this cosmic vanishing act? One leading theory points to an unseen planet lurking in the distant shadows. Imagine a massive world several times the size of Earth, whose gravity has swept the outer Kuiper belt clean of debris. This hypothetical planet 9 could be the invisible architect of the cliff, though no one's spotted it yet. Others suggest a more violent past. Perhaps a passing star or a rogue planet disrupted the Kuiper belt long ago, flinging objects into deep space and leaving behind this stark divide. Or maybe it's not about what's missing, but what we're missing. Our telescopes simply haven't spotted the faint, distant objects that could fill the gap. But here's the twist: the Kuiper Cliff isn't just a curiosity, it's a clue. If an unseen planet is responsible, finding it could rewrite our solar system's history. If it's a relic of ancient chaos, it reveals how dynamic and unpredictable our cosmic neighborhood once was. And if it's just a matter of observational limits, well, that's a reminder of how much we still have to learn. As we stand at this celestial precipice, our next mystery pulls us even deeper into the cosmos, where geometric perfection defies nature's usual chaos, the Red Rectangle Nebula. Now, shifting our gaze from the stark emptiness of the Kuiper Cliff, we arrive at a cosmic spectacle that seems almost too perfect to be natural: the Red Rectangle Nebula. Nestled in the constellation Monoceros, this celestial oddity stands out like a meticulously crafted piece of art amidst the chaos of space. What makes it so extraordinary? Its shape, unlike most nebulae which billow and swirl in organic, irregular patterns, the red rectangle boasts near-perfect geometric symmetry. Imagine an enormous, glowing X marked by crisp, straight lines, all encased in a rectangular halo of crimson light. It's as if the universe decided to break its own rules of randomness and create something unnervingly precise. So, how does something like this form? The secret lies at its heart: a binary star system. Two stars locked in a tight orbital dance are responsible for this masterpiece. As one star nears the end of its life, it sheds layers of gas and dust, which are then sculpted by the gravitational tug of war between the pair. The result, a stunning, symmetrical outflow that defies the usual messy chaos of stellar death. But there's more to the story. The nebula's dust particles play a crucial role too. Scientists believe these tiny grains are aligned in a way that polarizes light, enhancing the rectangular illusion. It's a cosmic trick of perspective and physics, where dust dynamics and stellar interactions conspire to create an optical marvel. Could this be a glimpse into the future of our own solar system? One day, the Sun will shed its outer layers, forming a nebula of its own, though it's unlikely to resemble anything as orderly as the red rectangle. This nebula's eerie symmetry is a rare cosmic fluke, a reminder that even in the vast, unpredictable universe, beauty can emerge from the most unexpected processes. As we marvel at this geometric wonder, our next mystery takes us closer to home, to the red sands of Mars, where another enigma lingers, the puzzling fluctuations of methane in its thin atmosphere. Now, let's turn our attention from the geometric wonders of deep space to a mystery brewing right next door on the rusty surface of Mars. Here, scientists have been tracking something peculiar: the unpredictable rise and fall of methane in the planet's thin atmosphere. Methane is a gas that shouldn't just appear and vanish without a trace. On Earth, it's often produced by living organisms, think cows, wetlands, or even microbes deep underground. But on Mars, its presence is far more puzzling. Detections by rovers like Curiosity have shown methane levels spiking and then dropping dramatically, sometimes within just days. This erratic behavior has left researchers scratching their heads. So, where does this methane come from? There are two leading theories. The first points to geology: processes like serpentinization, where water reacts with certain rocks, could release methane. The other, far more tantalizing possibility is biology. If microbes exist beneath Mars' surface, they might be producing this gas, just as their earthly counterparts do. But here's the twist: methane on Mars doesn't stick around for long. Solar radiation and chemical reactions should break it down within a few hundred years, maybe even faster. So, if we're detecting it now, that means something is actively replenishing it. Whether it's geological activity or hidden life, the source is likely still at work today. This mystery isn't just academic, it's a potential game changer in the search for extraterrestrial life. If the methane turns out to be biological in origin, it would be the strongest hint yet that we're not alone in the universe. But even if geology is the culprit, understanding these processes could reveal hidden reservoirs of water or energy, reshaping our picture of Mars as a lifeless world. As we ponder the secrets lurking in Mars' thin air, our next cosmic conundrum pulls us toward Saturn, where a massive, six-sided storm swirls in defiance of everything we know about planetary weather. Now, shifting our gaze from the dusty plains of Mars, we arrive at a spectacle unlike anything else in our solar system: Saturn's mesmerizing North Pole, where a colossal hexagon-shaped storm has raged for decades. This isn't just any weather pattern, it's a near-perfect geometric wonder, spanning roughly 20,000 miles across, wide enough to fit two Earths side by side. And here's the kicker: while storms on Earth come and go, this one has stubbornly held its shape since we first spotted it in the 1980s. So what's behind this six-sided enigma? Scientists believe it's all about fluid dynamics, the way gases and liquids move. On Saturn, where the atmosphere is mostly hydrogen, jet streams whip around the planet at dizzying speeds. One leading theory suggests that these fast-moving currents, interacting with Saturn's rotation, create standing waves that lock the storm into this hexagonal shape. Think of it like water swirling in a bucket. If you spin it just right, you might see patterns emerge, but nothing as precise or long-lasting as this. What makes Saturn's hexagon even more baffling is that Earth has nothing like it. Our planet's weather is chaotic, driven by a mix of oceans, land masses, and a thicker atmosphere. Saturn, by contrast, is a gas giant with no solid surface to disrupt its atmospheric flow. That lack of friction, combined with its rapid rotation, a day on Saturn lasts just 10.5 hours, creates the perfect lab for these bizarre, stable structures to form. But the mystery deepens. Why a hexagon? Why not a pentagon or an octagon? Some researchers point to laboratory experiments where spinning fluids naturally form six-sided patterns under certain conditions. Others speculate that deeper layers of Saturn's atmosphere or even its magnetic field might play a role. Yet despite decades of data from missions like Cassini, no model perfectly explains why this shape persists or why it's only at the North Pole. As we marvel at this cosmic puzzle, remember, Saturn's hexagon isn't just a curiosity. It's a window into how planetary atmospheres behave under extreme conditions, offering clues about weather patterns on distant exoplanets. And with that, we turn to another cosmic head-scratcher, the universe's puzzling shortage of lithium, a mystery that challenges our very understanding of the Big Bang. Now, let's zoom out from the peculiar storms of Saturn to a puzzle that stretches across the entire cosmos, the universe's baffling lithium shortage. Here's the problem. According to the Big Bang theory, the early universe should have produced a specific amount of lithium, along with hydrogen and helium. But when astronomers measure lithium levels in ancient stars, the cosmic relics of that primordial era, they find only about 1/3 of what the models predict. It's as if 2/3 of the universe's lithium has simply vanished. So where did it go? One possibility is that our understanding of nuclear physics in the early universe is incomplete. The Big Bang's fusion processes might have worked differently than we think, leaving less lithium behind. Alternatively, lithium could have been destroyed over time, swallowed by stars, broken apart by cosmic rays, or transformed by interactions with dark matter. Some theories even suggest exotic particles like actions could have played a role in depleting it, but the plot thickens. Younger stars like our Sun also show less lithium than expected, hinting that the problem isn't just about the Big Bang. Could there be a universal mechanism, something in the way stars evolve, that steadily erases lithium from the cosmos? Or are we missing a fundamental piece of the puzzle, like an unknown particle or force? This isn't just a quirk of chemistry. Lithium is a key piece of the cosmic inventory, and its absence forces us to question whether we've got the early universe's recipe right. Solving this mystery could reshape our understanding of everything from stellar evolution to the fundamental laws of physics. And with that, we turn to another cosmic outlier, a galaxy that defies one of astronomy's biggest theories by existing without dark matter. Now, shifting our gaze to a cosmic rebel that refuses to play by the rules, let's talk about the galaxy that shouldn't exist, NGC 1052DF2. This strange celestial object has astronomers scratching their heads because it appears to have almost no dark matter, the invisible glue that supposedly holds galaxies together. Here's why this is so shocking. For decades, dark matter has been the cornerstone of our understanding of how galaxies form and behave. Without it, galaxies like our Milky Way would fly apart, their stars moving too fast to stay bound by gravity alone. Yet NGC 1052DF2 defies this logic. Its stars move at speeds that match the gravity of its visible matter, as if dark matter simply forgot to show up. So what's going on? One possibility is that we're misreading the data. Maybe the galaxy's distance was miscalculated, throwing off our measurements of its mass. Or perhaps its stars are arranged in a way that tricks us into thinking dark matter is missing. But even after double-checking, the anomaly persists. Another theory is more dramatic. Some scientists suggest this galaxy might have been stripped of its dark matter in a violent cosmic encounter, like a collision with another galaxy that ripped the invisible stuff away. There's even a wilder idea that dark matter and regular matter can somehow separate under extreme conditions, leaving behind a ghostly galaxy of stars alone. Whatever the explanation, NGC 1052DF2 forces us to rethink one of astronomy's most basic assumptions. Could there be entire populations of dark matter-free galaxies hiding in plain sight? Or is this bizarre object a fluke, a cosmic prank designed to keep us guessing? Either way, it's a reminder that the universe still has plenty of surprises up its sleeve. And with that, we turn to another enigma written in the oldest light of the cosmos, the mysterious cold spot in the cosmic microwave background. Now, let's journey back in time to the very dawn of the universe, where an eerie chill lingers in the cosmic microwave background, the afterglow of the Big Bang. Nestled within this ancient light is a puzzling anomaly known as the CMB cold spot, a region significantly colder than its surroundings. This isn't just a minor temperature dip. It's a cosmic oddity so large and so cold that it defies easy explanation. At first glance, you might think it's just a statistical fluke, a random quirk in the data. After all, the universe is vast and oddities can pop up by chance. But the cold spot is so extreme that the odds of it being mere coincidence are astronomically low. This has led scientists to dig deeper, proposing some truly mind-bending possibilities. One theory suggests the cold spot could be a cosmic texture, a remnant of exotic physics from the universe's earliest moments. Imagine spacetime itself knotting up like a tangled thread, leaving behind a faint imprint in the form of this chilly void. Another idea points to a supervoid, a colossal emptiness in space where fewer galaxies and less matter mean less gravitational pull, subtly cooling light passing through it. But even this explanation falls short, as the observed supervoids aren't large enough to account for the cold spot's intensity. Then there's the most tantalizing hypothesis of all, that this cold spot might be a bruise from a collision with another universe. In the multiverse scenario, our universe could have bumped into a neighboring one, leaving behind a telltale cold patch as evidence. It's a wild idea, but one that underscores how little we truly understand about the fabric of reality. Whether it's a cosmic glitch, a relic of the Big Bang, or a doorway to another realm, the CMB cold spot reminds us that the universe is far stranger than we can imagine. And as we ponder its mysteries, we're left with one burning question. What other secrets are written in the faint whispers of the cosmic microwave background? Next, we'll unravel another celestial puzzle, the zodiacal light paradox, where the solar system's dust shines brighter than it should. Now, let's turn our attention to a celestial glow that has puzzled astronomers for centuries, the zodiacal light. This faint, ethereal band of light stretches across the night sky, visible just before dawn or after dusk. It's caused by sunlight scattering off tiny dust particles scattered throughout our solar system. But here's the twist: there's more light than there should be, given the amount of dust we've detected. This is the zodiacal light paradox, and it's forcing scientists to rethink what's really floating around in our cosmic backyard. At first, you might assume comets and asteroids are the main culprits. After all, these rocky wanderers shed dust as they travel, leaving trails in their wake. But when researchers crunched the numbers, they found these sources simply don't add up to explain the brightness we see. The math falls short, leaving a glaring gap in our understanding. So where's the extra dust coming from? One possibility is a hidden reservoir, perhaps a vast cloud of particles lurking in the outer solar system, too faint for our telescopes to spot. Another theory suggests interstellar dust drifting in from beyond our solar system could be mixing with local debris and amplifying the glow, but the plot thickens. Recent observations hint that the dust might not be evenly distributed. Instead, it could clump in ways we haven't yet mapped, creating pockets of intense scattering. Or maybe the particles themselves are stranger than we thought, unusually reflective or shaped in ways that catch more sunlight. Whatever the answer, the zodiacal light paradox reminds us that even our own solar system holds unsolved mysteries. It's a humbling thought. After centuries of study, we're still uncovering surprises in the dust beneath our cosmic feet. Next, we'll venture into the quantum realm, where an elusive effect predicted decades ago continues to defy detection, the Unruh effect. Now, let's step into the strange and shimmering world of quantum physics, where even empty space isn't as empty as it seems. The Unruh effect is one of those mind-bending predictions that sounds like science fiction, but it's rooted in some of the most rigorous math in physics. Imagine this: if you were floating in the vacuum of space perfectly still, you'd feel nothing but cold, dark emptiness. But if you started accelerating, really zooming through that void, something bizarre would happen. The universe would suddenly seem to heat up around you, as if you'd plunged into a warm bath of particles. That's the Unruh effect in a nutshell. Acceleration makes particles appear where there were none before. The wild part: this isn't just a quirky thought experiment. The effect is deeply tied to how black holes radiate energy, a discovery made by Stephen Hawking himself. In fact, the math behind the Unruh effect is eerily similar to Hawking radiation, the glow that slowly leaks from black holes. Both phenomena suggest that what we perceive as empty space is anything but. Instead, it's a seething quantum foam where particles flicker in and out of existence depending on how you're moving through it. But here's the catch: proving the Unruh effect is incredibly hard. To feel that phantom heat, you'd need to accelerate at rates far beyond anything humans or even our sturdiest machines can handle. We're talking speeds that would turn a spacecraft into a pancake in seconds. So physicists have gotten creative, designing lab experiments that mimic those extreme conditions using clever tricks with lasers and supercooled atoms. Some teams have even proposed using high-energy particle collisions as a shortcut to spot the effect. Yet, despite decades of effort, no one's definitively caught the Unruh effect in action. It's a ghost in the quantum machinery, always slipping through our fingers. Some wonder if our current tools just aren't sensitive enough, or if there's a deeper layer of physics we're missing. Either way, the hunt for this elusive phenomenon keeps pushing the boundaries of how we test the universe's weirdest rules. Up next, we'll tackle a mystery that's splitting the cosmology community wide open: the Hubble tension, where the universe's expansion rate refuses to add up. Now, let's turn our attention to a cosmic puzzle that's making astronomers scratch their heads: the Hubble tension. At its core, this mystery is about a simple question: how fast is the universe expanding? You'd think we'd have a clear answer by now, but the numbers just won't agree. Here's the problem: scientists use two main methods to measure the universe's expansion rate, often called the Hubble constant. The first relies on the cosmic microwave background, the faint glow left over from the Big Bang. By studying its patterns, we can calculate how quickly the universe should be expanding today. The second method looks at nearby stars and galaxies, measuring their distances and speeds directly. Both approaches are rock solid in theory, but in practice they keep giving us different results. The discrepancy isn't huge, but it's stubborn. And that's got physicists wondering if something fundamental is missing from our understanding of the cosmos. One possibility: dark energy, the mysterious force driving the universe's accelerated expansion, might be changing over time. Maybe it's not as constant as we thought, subtly tweaking the expansion rate in ways we haven't accounted for. Others suggest there could be unknown particles or forces at play, quietly influencing how space stretches. Then there's the less exciting but equally plausible explanation: maybe there's a hidden error in our measurements. Perhaps dust, calibration issues, or other sneaky biases are throwing off one or both methods. The stakes are high. If the tension points to new physics, it could revolutionize cosmology, forcing us to rewrite the rules of how the universe works. But if it's just a measurement glitch, it'll be a humbling reminder of how tricky it is to pin down the cosmos's secrets. Either way, the Hubble tension isn't just a technical hiccup, it's a doorway to deeper questions about the nature of reality itself. And with that, we've reached the end of our journey through 25 of the universe's most baffling mysteries. From gravitational anomalies to phantom signals, each one reminds us how much we still have to learn about the cosmic void. So tell us which mystery left you the most awestruck. Drop your thoughts in the comments below, and don't forget to subscribe for more deep dives into the wonders of space. The universe is full of secrets waiting to be uncovered, and we'll be here to explore them with you. As we wrap up this cosmic journey, it's humbling to realize just how many unanswered questions still linger in the vast expanse of space. From the Great Attractor's invisible pull to the eerie uniformity of dark flow, from the haunting silence of the Fermi Paradox to the fleeting whispers of fast radio bursts, each mystery we've explored today is a reminder that the universe is far stranger and more enigmatic than we often imagine. Think about it, we've mapped galaxies billions of light years away, yet we can't explain why half the universe's normal matter is missing. We've detected methane on Mars, but we still don't know if it's a sign of life or just geological quirks. And let's not forget Oumuamua, the interstellar visitor that defied all expectations, leaving us to wonder whether it was a cosmic iceberg or something far more extraordinary. These puzzles aren't just scientific curiosities, they're invitations. Invitations to keep questioning, to stay curious, and to embrace the thrill of the unknown. Because every mystery solved opens the door to 10 more, and that's what makes exploring the cosmos so endlessly fascinating. So now it's your turn. Which of these 25 cosmic conundrums left you staring at the night sky with wonder? Was it the chilling cold spot in the cosmic microwave background, the hexagonal storm raging on Saturn, or maybe the unsettling alignment of the axis of evil? Drop your favorite in the comments below. We'd love to hear which mystery sparks your imagination. And if you're hungry for more deep dives into the universe's greatest secrets, don't forget to hit that subscribe button and ring the notification bell. The cosmos is full of stories waiting to be told, and we'll be here to uncover them together. Until next time, keep looking up because the universe always has another surprise up its sleeve.